All right, welcome. Happy Thursday morning. I hope that we've all been doing good. We're going to keep going and chug right on into 7.3. There are two more cases that we've not talked about. If you remember from the beginning, there's four total um, with triangles, angle, um, side, angle, side, angle, angle, side, or side, side, side. The last two cases, the cases 3 and 4, we'll be talking about the side, angle, side, and the side, side, side. Okay. The deal with this one is you're not going to have an angle and a side opposite it in these cases. Okay. So I'm going to talk about one thing. Let's recall from geometry. Okay, there was a theorem somewhere or a postulate that said the sum of the lengths of any two sides of a triangle must, that's a big must, be greater than the length of the remaining side. Greater than the length of the third side. So you can be given three numbers and it not actually form a triangle. We need to kind of keep that in the back of our brains, okay? Not saying that's going to happen a lot, but it might happen a time or two, okay? To where you're given the numbers 4, 5, and 10. Okay? A is 4, B is 5, C is 10. Find all the angles. Okay? Now, if you were going to draw this out and we would pretend that this length is 4, this length is 10, and this length is 5. Okay? If this is 4 and this is 5, this will not connect. It will not make a triangle at all. Okay? So let's keep that in the back of our brains. In geometry, we would say that's not a valid triangle. Okay, so we can't just make up numbers. I can't just make up numbers. I know you don't ever do that, but I do sometimes. So we needed another law to use if we're given just the sides or two sides and an included angle. Okay, so if we're given two sides and an included angle of, it doesn't matter, 10 and 15, and we're given an angle of 50 degrees, okay? Well, if we go ahead and draw these two lengths, it can't move, we'll have to be coming this way. Don't worry, there won't be any time where there's two triangles in this case, because if we have a side, angle, side, and two triangles, it proves exactly one triangle is out there, okay? There's no two triangles, there's no zero triangles if we have this. But with a law of sine, you had to have an angle and an opposite side. You're thinking, well, I could just do the Pythagorean theorem and find that third side. But the issue is, this is not necessarily a right triangle, so the Pythagorean theorem will not work. Okay, so they do a wonderful deriving of the law of cosine, okay, and it looks very similar to the Pythagorean theorem, okay. Law of cosine, I don't know if you touched on it very much in Algebra 2. I always like to write, they give you three different, but c squared equals a squared plus b squared. But since this is not a right triangle, we need another piece to it. So we actually will subtract 2 times AB cosine of angle C. Okay? Oh, that's a lot. It's a good formula. They write it 3 times to where, are you missing side C? Are you missing side A? Are you missing side B? Okay? So I'm going to go ahead and write it 3 times just because that's what they do. So b squared equals a squared plus c squared. so the other two sides, minus 2 times the ones that we've just put here, 2AC cosine of the angle opposite the side we're trying to find. So it would be cosine B. Okay? It probably is a good idea to write these 3 times just so you have a little bit more familiarity. I don't know. That's the word. A squared equals B squared plus C squared minus 2BC cosine of angle A. Okay? So, this would work. We're going to pretend this is angle C that I give you, and we're going to solve for little c, A, and B. So this would be my little a, this would be my little b. If we were to plug this in, we would have to solve for the missing side length. We do always want to solve for the missing side length. Okay? So here we go. I'm going to change colors. So I would say c squared equals a squared plus b squared minus 2 times a times c times cosine of angle C, cosine of 50 degrees. Okay? Now, we just need to solve. All of this we can plug in our calculator. I think I have my calculator pulled up. Let's clear stuff from earlier. I'll probably run off the board a little bit. That's okay, because I don't start. Now, if you want to plug this all in, if you want to put it in pieces, I like pieces, you know that. But it is doable, and maybe we won't mess up if we're just plug it all in. Because multiplication, exponents, your calculator knows to PEMDAS times cosine 50. I'm just going to close that parentheses. We've plugged it in exactly like it is on our calculator, on our equation. Okay, I'm going to hit enter, and it gives me this big number, 132. Could C possibly equal 132? Oh, I need units, don't I? Sorry. Let's just put meters. Let's do meters. Could C possibly equal 132 meters? Is that plausible? Absolutely not. Based on what we just said that we need to recall from geometry. 10 plus 15 is not greater than 132. Oh, wait, let's keep going. I had that's C squared equals 132.16, yada, yada, yada. I'm keeping it all in my calculator anyway. So I'm simply going to put second square root, second answer. Give me the square root of that, which is 11.5. So C equals 11. I'm just going to put 11.5. I know that is not sig figs, because if it was, it would be 11. But I just can't do that. It's 0.49. It's too much of in the middle. Okay? So I would say C equals, or it's approximately, because I did round, 11.5 meters. Okay? Now, the question is, could we now find all the other missing pieces? Could we find angle A? Could we find angle B? Yes, we can. And now that we have an angle and a side opposite it, guess what we can use? That's right, the law of sine. So, a little side note, when we're using the law of cosine, you should only ever have to use it once to find that missing side. But, I don't know if you realize, I left that in my calculator because I don't want to round when I'm finding things, okay? Even though I'm going to put 11.5 here, I'm still going to have all those decimals in my calculator. 11.5 over sine 50 degrees equals, and somewhere it's going to tell us. Yeah, there's something we need to talk about first because it's going to matter on some problems, okay? There's a wonderful big box on the bottom of page 322 that is talking about what to do. In case 3 and 4, we really need to pay attention to, okay? In a side angle side, we're going to find the third side using the law of cosine. We've done that. But then the second step is very important. We're going to find the smaller of the two remaining angles. I'm going to write all these out in just a minute. But it's going to matter. I need to find the smaller. How do we know which angle is smaller? Shortest side will always be opposite the smallest angle. Okay? So then we would use 10 over sine B. We're going to cross multiply. We have 10 sine 50 equals 11.5 sine B. So now I've got to divide by 11.5. Okay? Then we'll pull out my calculator. I'm going to scroll it over here. So I'm going to take this number, 10. Well, actually, I tell you what, I'm going to put parentheses. 10 sine 50 in parentheses divided by second answer. That way I get that 11.49, all that. Okay? This is 0.6663430, yada yada. Second sine, second answer. It's 41.78. So if I was rounding that up, it would be 42. I'm just going to put 41.8 for now. Here we go. We'll just leave it here. B equals 41.8 degrees. If that's the case, if B equals 41.8 degrees, how could we find angle A? That's right. I could just simply subtract 180 minus 50 minus 41.8. I still don't have my calculator. So here we go. So 180. Now, this case, I'm not going to keep all those decimals because my angles in a triangle need to add up to 180. So I don't want to leave any error for that. So angle A would be 88.2 degrees. Okay? You guys, great. We can solve this. But I am going to write down some of our rules. Suggested procedures for solving. In this case, that triangle, it wouldn't have made a difference, actually. Okay, because angle A was an acute angle. But if angle A had been an obtuse angle, it would not have given us that obtuse answer. Okay, just so you know. So if you're given a side, angle, side, here's what we're going to do. Our first step, we're going to find the missing side. Using the law of cosine. Okay? Second, we're going to find the smaller of the two angles using the law of sine. Okay. Third, or last, you're going to find the remaining angles. Fine, I'll just put last. Last angle by subtracting. From 180 degrees. Okay? Now, we're going to do one more of the side angle sides, and maybe we'll do side tomorrow. Can't remember what time we started. All right, here we go. So we're going to remember these rules. This is very important with a side angle side. Okay? With the law of cosine, we're going to have some specific steps that we need to use. Okay? So, if you have, here's an application, that's a good one. A surveyor wishes to find the distance between two inaccessible points A and B on opposite sides of a lake. While standing at point C, she finds that AC is 259 meters. Okay? She finds that BC is 423 meters. And that angle C will equal 132 degrees, 40 minutes. I know how you guys like that. Find the distance from A to B. Okay, we can see it drawn out if you need to see it drawn out. There's a point here that's A, there's a point down here that's B, and a point over here that's C. And the distance from A to C is 259. The distance from A to B is 423. And this angle in between is 132 degrees, 40 minutes. And we're trying to find the distance from A to C. I'm going to put that as an X, our unknown. Okay? So what type of triangle do we have? We have a side, angle, side. So we're going to go through our steps. And they only want this distance. So we can say x squared equals the 259 squared plus 423 squared minus 2 times 259 times 423 times cosine of 132 degrees, 40 minutes, not degrees. Okay? Now, if I was doing that piece by piece, those numbers are going to get very big very quickly. Okay? So I am just going to plug it all in my calculator. Okay? So 259 squared plus 423 squared. Oh, what? I cleared the whole thing, sorry. 259 squared plus 423 squared minus 2 times, you can put parentheses or times, it should not matter, it won't matter, times 423 in parentheses times cosine of 132, and I'm going to use my angle, 40 minutes. If you forgot that, in parentheses, I don't know if I need in parentheses, hopefully it's all there. Enter. Whew, 394,510. That's my x squared. Equals 394,510, point, etc., etc., etc. I'm keeping all that in my calculator. And I'm going to hit second square root, second answer, and I'm going to get 628.1 meters. That one I'm definitely going to round. Okay, 628 meters. Does it make sense that it's a lot bigger than the other two sides? Yes, largest angle, opposite longest side. Okay? It must be bigger. Use some logic sometimes when you're getting your answers. Does it make sense? Okay? This one, that's all they asked for. You don't have to find the other two angles. Okay? So I'm going to give you a problem to do. I'm going to give you two problems to do for today. Okay? Solve triangle. ABC if angle B is 73.5 degrees, side A is 28.2 feet, and side C is 46.7 feet. Okay, solve the triangle. Missing sides, missing angles. Okay, so this is your problem number 1. And your problem number 2. Okay, 2 boats leave a harbor. Oh, I don't want to write all of it out. 2 boats leave a harbor. At the same time, traveling on courses that make an angle. Okay, so I'm just going to write angle between. So they go in different directions, and the angle between them is 82 degrees, 20 minutes. When the slower boat has traveled, okay, slower boat has traveled 62.5 kilometers. The faster one has traveled, they're going different speeds, 79.4 kilometers. At that time, what's the distance between the boats? Okay, so I'm going to kind of highlight some things. You've got one boat that's traveled 662.5 kilometers, another boat that's traveled 79.4 kilometers, and the angle between them is 82 degrees, 20 minutes. Okay, what's the distance between the boats? Happy Thursday. This is all that I'm leaving for you. We'll do side tomorrow, and maybe talk about another area formula. We'll see. All right. You've got this. Happy Thursday. Bye.